notepad. Okay, mag-notepad tayo. Because in source transformation, the theorem that we're going to use, is Ohm's law only. Okay. Once you've mastered the Ohm's law, then you'll be able to perfect the source transformation without a problem. Okay. So this is optional. You can also use KVL. Okay, but we're going to use purely Ohm's law. You can also apply KCL. Okay, but then again, you can uh, also use Ohm's law only. Okay, so I is equal to V divided by R, or V is equal to I and then R. So KVL is used to get the voltage, and then KCL is to get the current. But in Ohm's law, we can already have that one since we have that formula, okay, in Ohm's law. So the V is equal to IR, and then I is equal to V divided by R. Okay, so let me divide the source transformation into two. So we have voltage. So since ito kasi yung laging meron tayo, voltage source, and then we also have a current source. Okay, so as it names implies, we're going to convert, okay, a voltage source into a current source, or vice versa. Okay, so dito ko nang ilagay vice versa, from current source into a voltage source. Okay, so let's divide those two. Okay, so here are the requirements, and then on this side are the let's say results. So from voltage source to current source muna tayo. Okay, from voltage source going to current source. Tanggalin ko na lang to. Confusing. Ayan na lang. Okay, so the requirement for you to be able to convert a voltage source into a current source is they must be, or ito na lang, isang word na lang, it must be in parallel. Mali, baliktad. It must be in series rather. Okay, it must be in series. Naman i-align. Okay, wait a second. So it must be in series going to parallel. Okay? So dapat yung voltage source nyo is in series with the resistor. So saan siya series? Series siya sa resistor mo mismo. Ayan. Okay? And then as a result, magiging parallel na yung connection nila. So later on, you will see this transformation from series to a parallel. Okay? So yun lang naman yung pinaka-requirements para ma-transform natin ang voltage source into a current source. So from here, you can already use I is equal to V divided by R. Okay? Oops. What happened? May umalis. Okay, I thought I got disconnected. So ngayon, tatlo na lang kayo. Apat pala. Wala nang pawala. Pag naging dalawa na lang kayo or isa, hindi na ako magdi-discuss. Bahala na kayo. Siyempre, nakakatamad ding mag-discuss kapag walang pumapasok. So, parang taken for granted kasi recorded naman. Tapos, panoorin ko na lang mamaya. Ganun. So, papaisip tuloy ako kung i-record ko pa ba or hindi. Well, anyway, so let me just check. Are you guys still around? Mr. Carlo, Mr.
Yes, sir.
Francis,
Dito pa po, sir.
Yes, sir.
Mr. Sajin, and then Miss Grace.
Yes,
So
sir.
three boys and one girl. Okay, anyway. So, ngayon pala nagpapasalamat na ako. I really appreciate your presence right here now, guys. Because without you guys, hindi ako may inspired na magturo. Okay, bakit ko pa ituturo to kung hindi naman kayo interesado makinig? Okay. So, mas okay pa yatang mag-record na lang ako and then ibigay ko na lang sa inyo yung recorded video. Well, anyway, so yeah. We have this requirement, kahit isa lang, requirement and then result. Okay? So, we can also do the vice versa, of course, from current source to a voltage source. So of course, just do the opposite of this one. Okay, so this one must be in parallel. Okay, so if you're going to analyze the circuit, it must be in parallel with the current source. Okay, with the resistor, and then as a result, okay, just apply VIR, and then as a result, you will have a series connection right here. Okay, then after that, because our main goal and why we are applying source transformation is to have a series connection. Okay, this one is kind of similar with the what is the theorem? Yeah, the Norton's theorem and then Thevenin's theorem. So we are solving for a specific path. Let's say we are trying to get the voltage across that path, or we are trying to get the current on that certain path. Okay, because if we have a series connection, we can easily solve things without a problem just by applying Ohm's law. All right. Anyway, so let's have this put aside for now. So we'll go back to this notepad later on. So just a little background of study. So it is an electrical network can consist of sources and passive elements. So sources could be current source or a voltage source, and then passive elements are of course the resistors, capacitors, inductors, and then passive, not passive, and yeah, so halo kasama pa yun. So those are the only passive components. And then we can divide these sources into two. Okay. So other than having a current source and then a voltage source, we can also have an independent source and a dependent source. So as its name trying to imply, independent stands alone. It doesn't depend on the other components or on the passive components. But a dependent source, okay, so the value of the voltage or current depends on the amount of current or voltage elsewhere. Okay, so meaning this one is dependent on one or two components that you have on your electrical circuit. Okay. Well, anyway, let's have a further explanation on why we have this source transformation. So knowing that, the complexity of electrical networks ranges from very simple, okay, let's say a voltage divider, into a very complicated internal structure of an integrated circuit, okay. So if you're a good analyzer, or let's say you're an expert when it comes to analyzing designs, okay, you will easily know that a good electrical designer is expected to have a sound knowledge of the entire system irrespective of its complexity. So no matter how complex it is, let's say we have a bunch of wires, a bunch of resistors, you can easily simplify that one into a super simple circuit. Okay, like for example, you have a lot of resistors. You can just add them in one single value, like applying a parallel law or a series law for the resistance. So the same with the sources. Okay, you can easily let's say convert that voltage source into a current source, and then if you have multiple sources, you can combine them as one. Okay, so that's basically the benefit of learning about voltage. I mean, uh, source transformation, the voltage to current and then current to a voltage. Okay, so with that, you will be easily identify, okay, on how to simplify this circuit. Okay, no matter how complex it is. Okay, and this is also absolutely essential when the issue arises of upgrading or troubleshooting the system. Okay, so this is where the electricians will be coming from. So iniisa-is nila, i-check nila by using voltmeter or the VOM. Okay, so is this working? Do we have the voltage right here? Do we have the current right here? Okay, and so on and so forth. And then from there, you will easily or they will easily be able to identify the problem. Okay, and then of course with the help of the theorems. So dapat in-expect nila yung voltage or yung current na dumadaloy dito is something like this. Yun kasi yung parang nasolve nila according from the values of those resistors and then the voltages. But if that is not the computed value, let's say using the VOM, then there must be something wrong with the connection. Okay. So at this point, it is essential to note that analyzing an electrical circuit is sometimes easy and straightforward, taking only a couple of minutes in its entirety. Sometimes, though, it can involve a lot of hard work Okay, or rather smart work. So dito na pumapasok yung ito na kasing modern ngayon eh. Before, they are really analyzing it one by one. But right now, we just, with our technology, I saw a technology wherein they will just take a picture, okay, of that PCB or circuit board, and then that picture will be imported to a certain application, and then matara-transform na siya into skeletal electrical circuit, like parang yung sa LT Spice nyo. Okay, so parang ganun na siya. So with that, they will easily identify the flow of current on this path, the voltage on this path, and so on and so forth. Okay. So, yeah. Well, of course, with the help pa rin ng theorem kung sakaling hindi ka sigurado kung gano'n ba talaga yung connection nun. Okay? So, you have to verify that one, okay, using some basic rules and then some basic theorems. Okay? Well, anyway, so that's it for the background of study when it comes to this source transformation. So here are the list of important theorems along with a brief explanation. So sinama ko lang dito just to recall. Okay, so when say superposition theorem again, so it aids in finding the current and voltage in a circuit which has multiple sources. So Thevenin's theorem and then Norton's theorem. So this will give you a simplified circuit. So Thevenin's theorem will give you a series connection, and then Norton's theorem will give you a parallel connection. Okay, but of course, with a single resistor. So yun lang naman yung parang similarities nila. And then the rest, they differs when it comes to sources. So Thevenin's is voltage source, and then Norton's is with the use of a current source. And then Millman's theorem, so we haven't discussed this one yet, but this one is good when there's a lot of involved parallel branches. So pag marami tayong parallel connection, so we can just easily apply Millman's theorem and then find the specific value that we are looking for. Okay? So at this point, it should be noted that all these theorems are based on the basic rules governing the field of electronics, namely Ohm's law and Kirchhoff's laws. So these two are the foundations, okay, when it comes to everything, okay, or those theorems that we have just discussed. And then additional, okay, which we haven't discussed yet, okay, which will be discussed later on after this module. So we may sometimes find a circuit which has the resistors connected either in a delta or pi or star to Y or T configuration. So delta or pi, they are just the same. So sometimes it's called pi, sometimes it's called delta. So the same with this one. So sometimes it's called star connection or Y connection or T connection. Okay, or Y configuration or T configuration. Okay, so those three are just the same, just different terminologies. Okay, so in such cases, we can employ star to delta or delta to star to transformation when analyzing the circuit. So later on, I will discuss this one. So for now, wala pa siguro kayong idea what is this delta, what is this pi. But yeah, it's just a conversion, okay, from this to this or vice versa, from this to that. Okay, anyway, so let's start now with our first example. So let's have an independent source for now. Okay, so later on we're going to have an example for the dependent source. So our goal right here is to find the current, okay, denoted by I through the central 5 ohm resistor. So we have to find the current that is flowing on this, let's see, node X or this branch right here. Okay, so as you guys can see, we cannot just simply apply Kirchhoff's law, okay, or mesh current analysis. That's because we have this current source right here, okay. Well, we can transform this one first and then apply mesh analysis or Kirchhoff's law later on. But since we're talking about purely source transformation, we are not going to use that one to simplify or to find that specific I in here. So we're going to use simply or purely, okay, source transformation. Okay, so from here, let's go back with our notes. So as you guys can see right here, we can actually transform this one right here, this 1 amp and then 10 ohms into a voltage source. So this is a current, this is a resistor. So what is the requirement again? From current to voltage. So from current to voltage, they must be in parallel. Okay, and then just simply apply V is equal to I times R. Okay, so in here, so V is equal to I times R. So I is 1 amp and then R is 10 ohms. So very easy. 1 times 10 ohms is equal to 10 volts. Okay? So yan na yun. Ganun lang kasimple. So you have already transformed, okay, one source into another source. So from here, it will become something like this. Okay? So were you guys able to follow that one? So take note, from parallel, it became a series connection. So it's now in series with our resistor. So did you guys get that one so far? Hello, hello, hello? Hello? Anybody there? So isa pa lang to First step pa lang to. Marami pa tayong step. Baka akala nyo ito na yung last o yung pinaka-end. Hello? Are you guys still around?
Yes, sir.
Okay. Were you guys able to get this one? And how did we arrive from this, okay, from this parallel connection into this series connection? Hello? Nakasunod ba kayo?
Yes, sir.
Imposibleng hindi. Nag-apply lang tayo ng V is equal to I times R. Yan lang yun. Okay? So, from here, okay, one thing that you will notice is you have to decide, okay, the polarity of your voltage source. So, is it right here or right here? So, that one will depend on the flow or the arrow where it's pointing the current, okay, or the arrow that's pointing. So, if it's going to left, then the left side will be your positive sign. Okay, and then the tail is of course the negative side. So, ganun lang siya. Okay? Then after that, you can now simplify this one a little bit more. So again, our goal is to arrive with a series connection. So dapat ganito lang siya. Into one source, and then let's say you can have another resistor right here and then another resistor. So that's our goal on this circuit right here. So from here, we can arrive with this kind of circuit. So how did we arrive with this one? So we just simply added the resistors. So 10 ohms plus 5 ohms is 15 ohms. And nothing happened on the left side since wala namang ibang resistor dun. And then from here, you can arrange this one into something like this. Okay, so we have the 10 volts right here. And then napunta na rin dito yung 5 ohms. So the same on the right side. So nandito na yung nandito rin yung nandito pa rin yung resistor natin. But our voltage source right here is move in here. So with that, we can easily identify again which source we can transform into another source. Okay, so from here, as you guys can see, we have a series connection. Okay, and then we have a series connection. So our uh, rule again when it comes to transforming a voltage into a current, they must be in series. Okay, so voltage source, so they must be in series, and then the result will become a parallel. So how will we get the current? So just apply Ohm's law. I is equal to V divided by R. I is equal to V divided by R. So in here, our voltage is 10. Okay, so sa left side muna tayo. And then our resistance is 5 ohms. So 10 divided by 5. Tama ba? Yeah, 10 divided by 5 is of course equal to 2 ampere. Okay, so this is the left side area. But what about the right side? So let's do the same. So 10 volts for the voltage and then 15 for the resistance. 10 divided by 15 is equal to 1/3. 2/3. Okay, or I think this one is 0 point something. Where is my calculator? Divided by 3 is equal to 0 0.6667 or 0 0.67 ampere. Okay, so after transforming that one, of course, this series connection, okay, will become a parallel connection. So ito na sila. Okay, we have 2 amps right here, and then we have the 2/3 amp right here, or the 0 0.67. Okay, and then from here, okay, here's a good thing when it comes to a current. So as you guys can see, we can easily add a current, okay, as long as they are in the same direction. So one thing that you will notice, our left side current is flowing from here to there, and then it will eventually flow on this node right here. Okay, and then this current will flow right here, and then it will eventually flow on this node right here. So as you guys can see, they will merge as one current. So 2 amps plus 2/3 is equal to 2.67 ampere. So we could say that it is now, okay, our current source right here, okay, which is 2.67 ampere. Okay, and then another thing, we can actually add already those three, but since we wanted to get the specific current that is flowing in here, okay, we have to combine only the 5 ohms and then the 15 ohms. Okay, and then as you guys can see, they are in parallel, so just apply the rules of parallel. So it will become, okay, so ano kaya ang pangalan nito? Well, anyway, so R na lang, pangalanan natin siyang R. So it will become a 5 times 15 divided by 5 plus 15. So 5 times 15 is 75 divided by 20. So this one now is equal to 3.75. Tama ba? 15 times 5 is 75. Yeah. Divided by 20 is 3.75. So it will give us a result of 3.75 ohms. Okay, for those combined resistor. So nandito pa rin of course yung resistor natin. Okay, so it's still in parallel connection. We just simply combine those two. So this will give us a result of 3.75 ohms. And then the 5 ohms will stay right here. Okay. And as you guys can see, we have to apply one more source transformation since our goal is to have a series connection. Okay, so let's go back with our notes. So from here, we applied a parallel connection with those 5 ohms and then 15 ohms. And then you will get this one, the same with what I have. 15 divided by 4 is 3.75. And then the current right here is 8 out of 3 or equal to 2.67 amps. Okay, so in here we're just using the uh, fraction. Okay, but in here I'm using the decimal uh, type of a number. Okay, and then from here we can apply again source transformation from current source to voltage source. So just simply use V is equal to I times R. So after that, you will have this computation. So V is equal to I, which is 8/3, and then times resistance, which is 15 divided by 4. Then after multiplying that one, it will give us the result of 10 volts, which is now this one. And then of course, from parallel, it will become a series connection. Okay. And then from here, you can now just simply uh, add those two, 15 divided by 4 plus 5 will give you the total resistance, and then eventually get the total current, which will give us the same result as 8 over 7 ampere. Okay, so in here I'm just showing that you can also apply KVL if you want, but you know, to to make it simple, you can also apply Ohm's law only. Okay, so since they are in series, you can just add them and then get the total current, and then whatever is the current that you will get, that's already the final answer. Okay, so I will not explain the KVL part anymore since it's already in here. You can just go back in here and then analyze this one again. But just to show you guys the Ohm's law formula, since I mentioned a while ago that we're going to purely use Ohm's law. So the RT for this one is equal to 15 divided by 4 plus 5. 15 divided by 4 plus 5 will give us a result of 8.75. Okay, and then of course in getting the current, it's I equal to V divided by R. So V is equal to 10 divided by R, which is 8.75. So this will give us the result of bakit iba ang sagot? Ay, tama. Okay, so it's 8 out of 7 or 1.14. Okay, or 1.14 amps. Okay, which is the same with this one right here, the 8 over 7. Okay, so we now have solved the current that is flowing on this branch right here. So are we clear with this one? Are you guys able to follow?
Yes, sir. Nagets naman po.
Yes, sir.
See? So napakadali lang nito. Ohms law lang and then you're good to go. As long as you know this rule right here. So screenshot nyo na lang to. Then okay na kayo sa source transformation. Sobrang dali lang nito. Okay, so we still have 2 minutes left. So let's try to maximize our time. So we have another example, but right now we're going to deal with a dependent source. Okay, so let's dive into the circuit right away. So again, I will leave the reading part to you guys. So in here, our goal again is the same. We have to arrive at this the same series connection. Okay, so how do we do that? So by simply applying source transformation. Okay, so in here, as you guys can see, we can actually split this one into two since they are in series connection. So if it's in series, as we all know, we have only one current that is flowing on that path. So we can do this kind of circuit right here. So we have 3 amps that is flowing on this 1 ohm and then 3 amps which is flowing on this 2 ohms right here. Okay, but since we have node in here, it's like they are now in a parallel connection. That is also due to this source right here. Okay, but anyway, so yeah, we can transform this one into this kind of circuit. So time check, 1 minute left. So we'll just continue the rest on the part 2. So goodbye for now and then see you guys later. Okay,
Yes, sir.
so yeah. Okay, so hello again. Okay, so let me just check if you guys are already in front of your computer. So again, just give me thumbs up. Okay, very good. So you guys can start eating now since it's already lunchtime. So same rule. So as long as we cannot see you eating and then we cannot hear you eating, then it's okay. Okay. So after transforming this one, so as you guys can see, we can now transform this one into a series connection. So how? Of course, by source transformation again. So from current into a voltage source. So in here, it will become something like this. So, imamano-mano na lang natin since I think kayang-kaya nyo namang i-analyze ng hands-on, okay, or via your mind only. So, current source to voltage source, so they must be in parallel, and then after that, they will become in series. So, V is equal to I times R. So, I is equal to 3 amps, and then R is equal to 1 ohm. So, 3 times 1 is 3 volts, and then naging series na sila. Okay, so the same with this one. So V is equal to I times R. So 3 times 2 is equal to 6 volts. And then we are now in series connection. And then wherever is your arrow pointing, that is your positive uh, symbol. Okay. So we have the positive right here and then positive right here. So yeah, that's it for the first transformation. So were you guys able to get that one?
Yes, sir.
Okay, very good. So as you guys can see, we have now here a triangle source. So this is actually the symbol, okay, of a dependent source. So if it's independent, it is a circle. But if it's dependent, okay, it is a triangle. And then mostly, if it's a voltage dependent source, okay, it comes with this letter I right here. And then vice versa, if this is a dependent current source, it has a voltage variable right here. So meaning it depends on the current that is flowing in here. Okay, so the voltage or the final voltage that will flow in here is being dictated by the current that will flow in here. So we have a larger current, then we have a larger voltage source right here. But if we have a lower, then of course a lower voltage source right here. Okay, so that's why it's called dependent source. Okay, and then another thing is we can now again arrange this one into something like this. Okay, so 3 volts and 1 ohm goes up right here, and then 6 volts and then 2 ohms. Actually, nandito pala, na-combine na pala to. So, ito muna. Let's combine these two first. So, 2 ohms and then 3 ohms. So, since they are in series, it resulted into 5 ohms. Okay. And then this voltage source also goes down on this branch right here. So, ito na siya. So the same with this one. So 1 ohm and then 2 ohm is in series connection. So just simply add those two. So it became 3 ohms now. And then this 3 volts right here goes up on this branch right here. Okay. And then the middle one stay the same as it is. So this is one thing that we should not touch. Okay. Since this is the one that we need to solve. Okay. The current that is flowing on this branch right here. Okay. So did you guys get this one on how did we arrive with this letter B figure?
Agad naman po, sir.
Okay, great. So just let me know if there's a part that you were confused or you wasn't able to follow. Okay, anyway, napaka-straightforward naman lahat ng mga circuits dito. So I think hindi kayo mawawala. Alright, so after that, okay, you can now transform this one, and this one into a another source. So from voltage sources into a current source. Okay. So why are we doing that one? Because if we have a current source, we can just simply add them as long as they are in, as long as we know their direction. So the same direction will be added, and then opposing direction will be deducted. Okay. So again, we also have the same rule. Whichever is the higher current, that's your first operand, and then whichever is lower, that will be your second operand. So there is no way that we're going to have a negative flow of current in source transformation. So it is always the higher current minus the lower current. Okay. So for the case number one, we have this computation right here. So I is equal to V divided by R. So V, ay, okay, bright. So V is equal to 3 and then R is 3 ohms. So 3 divided by 3 is 1 ohm. Okay, which resulted into this uh, current right here. Okay, so the same with this one. So V divided by R, which is 1 divided by this R, which is resulted into something like this, which is same with the case number 3. So V divided by R, which resulted into this formation right here, or this circuit right here. So I hope it's clear. So from series, of course, it became parallel connection. And then wherever is your positive sign, so of course, ganun din. So that is your arrow will be pointing, okay, for the current source. Okay, so I'll give you guys 10 seconds, 10 to 20 seconds to analyze on how did we come up from this circuit into this circuit. So, how was it? Were you guys able to get this one?
Yes, sir.
Yes, sir.
Nagets po.
Okay. So just in case you wasn't able to get it, so the explanation is on this left side right here. So after this, of course, we can now add those currents. So from here, we can add this one and this one. So 6 over 5, okay. Ang ginawa niya muna pala is yung opposing. Well, anyway, so let's put this one aside for now, the addition. So what he did first, okay, according from my presentation right here. So inuna niya to, okay, this 1 amp right here and then 6 over 5 amps right here. So again, whichever is a higher, that is your first operand. So since 6 over 5 is higher, so that is why we have 6 over 5 right here first, followed by the opposing current, which is 1 ampere. So 6 over 5 minus 1 is 1/5 ampere. Okay. And then for this one, you can now combine them as 1. Okay. So yung result nito na 1/5 will be added with this 1i sub 1 right here. So 1/5 plus 1i sub 1 is equal to 1 plus 5i sub 1 divided by 5. Okay. So just simply apply algebra, basic algebra, and then you will arrive with this kind of equation. Okay, or you can just simply eliminate the denominator by multiplying 5 on the entire equation, and then you will get this one. Okay, so after that, he did next is we can now combine, okay, those two resistor. So take note that we must not, okay, we must not touch this 5 ohms or this branch right here, which has an I sub 1, because this is the one that we are trying to solve, okay, the current that is flowing on this particular branch. So the only thing that we can do is we can add this 5 ohms and then 3 ohms via the rule of parallel connection, okay. So 5 times 3 divided by 5 plus 3 will give you 15 over 8 ohms, okay. And then after that, you can now have this as your final, not really final, okay, a semi-final circuit, okay. So we're almost near to this kind of circuit. So again, our goal is to have a series connection. So we have here the resistance, and then the current, and then the resistance, which is this one. So again, I'll give you guys 20 to 30 seconds to analyze this one. So if you don't have your calculator with you, you can just know the concept on how did we arrive with this 15 divided by 8, and then just verify these values later on. Okay. Well, I think madali lang. 5 times 3 is 15, and then 5 plus 3 is 8. So, ayan, nandun na rin pala. Okay, so how was it?
Sir, nagets naman po. Very clear naman po yung nakalagay, sir.
And then very,
Very clear, sir.
very clear. Okay. So, yeah, kaya hindi ko na pinapakita. Very detailed kasi. Okay. So, thanks to the reference where I got this one from. So, I think this one came from All About Circuits. So, mostly naman lahat galing sa All About Circuits. So, it is one good website that I found when it comes to electrical circuits. So, what about Mr. Francis and Mr. Michael and then Miss Grace?
Gets naman, sir.
Nagets naman po, sir.
Okay, very good.
Gets, sir?
So after this, so nakikita nyo na siguro kung paano ulit yung mangyari. So from current source into a voltage source. Okay? But before we can do that one, okay, so we have to parang simplify, okay, this equation right here. So, V is equal to I times R. So, ganun pa rin naman siya, I times R pa rin. Okay, however, so, hindi na siya kaagad-agad yung parang voltage na makukuha natin. Okay, so it comes with this letter I right here. Okay, so it needs a further simplification wherein we're going to need a it's either KVL or just simply Ohm's law. Pero I think mas so dito kasi parang mas okay na yung KVL. Okay. Since even though we know the voltage and then we know the total resistance, we won't be able to solve the voltage of this one, okay? Or the current of this one since we have a dependent variable right here. So in order for us to eliminate this one, we're going to use KVL so that we can combine those I1 and then we have another negative 5 I1 right here. Okay, so we can just combine them as one, okay, as one current, and then we'll arrive with a single current right here. Okay, so ganun lang naman siya. After transforming this one, you will have a 3 plus 15 I1, okay, divided by 8, which is now this one right here. So from parallel, it became a series connection now. Okay, and then from here, just apply KVL. So just simply follow the polarity of this one. So ito kasi yung kinukuha niya is yung inner. Okay, or ano bang inassume na okay. So hindi kasi ako sanay. So ang ginawa niya dito, okay. So ang ginamit niya is the other way around. So it's the current method. Okay. So kung ako kasi laging oops. Kung ako, laging clockwise. Lagi akong pa-clockwise. And then whatever is the sign right here, that is the one that I always get. So since we have a negative right here, we have negative, my bad, positive, negative, and then positive. Okay, para maging contradicting. Kasi magiging voltage drop dapat dito. So that's the only common sense or the common symbol for this resistance right here. So the same with this one. So we have negative and then positive. Okay, so just follow that one. It will give us a negative source, okay, which is this one, and then negative ay positive pala, positive 5 ohms, and then positive 15 divided by 8. Okay, so from here they will be added with each other. Or if you want to have the same let's say symbol whatever we have in here, okay, so just multiply this one by negative. So ito magiging positive na and then ito magiging negative, negative. So negative and then negative. Okay. So yeah, either of those two will be fine. So depende kung ano yung mas preferred nyo, it will give you the same result anyway. So again, if you got a negative current, just make that one positive and then ayun, just change the assume direction of your current. Okay? Kasi hindi yun yung tama. So in here, the correct flow of current is so yan, medyo pixelated na, nilakyan ko, is counterclockwise. Okay? So mangyari nito is positive, negative, and then positive, negative. So pag ganun. So positive yung voltage source, and then negative dito, and then negative ulit. Which is now the same with this one right here. Okay? So okay, so I think I need to explain this one. All right, so let's try to answer this one since this is our first time, okay, in solving a KVL equation with a dependent source. So what happened right here is, okay, move this one for now. Okay, so from here we have 3 plus 15 I sub 1 divided by 8. That is a positive voltage source. And then we have here negative 15 divided by 8 times I sub 1. Okay, because we only have a single current in here. Minus 5 I sub 1. I sub 1. Ito yung 1. Okay, is equal to 0. And then as you guys can see, we can actually combine these two since they have the same uh, the same unit. So 3 plus 15 I sub 1 divided by 8 minus 15 divided by 8 plus 5 is equal to 55 divided by 8 I sub 1. Okay, and then from here we can separate this 1 into 2 since they have the same denominator. 3 divided by 8 plus 15 I sub 1 divided by 8 minus 55 divided by 8 I sub 1 is equal to 0. And then from here, pwede na natin silang i-add lahat since they have the same denominators. Or just simply multiply everything to 8. Okay, so multiply everything to 8 para lang mapakita. And then everything will be cancelled. Okay, and then we now have here 3 plus 15 I sub 1 minus 55 I sub 1 is equal to 0. And then from here we can add these two since they have the same unit. So 15 plus 55, mali pala, negative 55. Negative 55 plus 15 since they have different tawag dito, symbol, okay, which is the other one is positive and then the other one is negative. So in here we have 3 minus 40 I sub 1 is equal to 0. And then this transpose this one on the other side. 3 is equal to 40 I sub 1, and then you can now find the I sub 1. I sub 1 is equal to 40, mali. 3 divided by 40. So I sub 1, ano ba nakalagay dito? Fraction din yata. So let's see. So there you go. We have the same result, which is 3 divided by 40 amps. Okay, so that is now the current that is flowing on this I sub 1 right here. So are we clear so far? Are you guys able to follow my solution, my messy solution?
Yes, sir. That's naman.
Yes, sir.
Okay,
Mm.
so yeah, you can use KVL, you can use KCL, so that completely depends on you. But you know, you can just simply use Ohm's law if you want, okay, as long as it's applicable. So okay, as a summary, okay, so we have this kind of series connection, then it can be transformed into this uh, circuit. So from series to parallel, from voltage to current, okay, and then vice versa, of course. From current to voltage, okay, you must have a parallel connection, and then it will go to series connection. And then wherever is your positive sign, okay, that's the arrow that will be, or that the arrow of your current will be pointing. Okay, oops. So the same with this one. It's just that the arrow is pointing downwards. Okay, so the same with dependent sources. So in here, it's just that we have this equation right here, okay, wherein let's say the I is dependent to voltage, or the voltage is dependent to I. So I drop those two. Okay, so they are depending with each other. So from voltage source to current source, and then wherever it's the sign, it is your arrow wherever it's pointing. So the same with this one. So we have a downward, or the positive sign on the below. So we have a downward current right here. Okay. So here are the sample videos. Well, you can also find this one on the watch videos, I guess. And then if you want to have a Tagalog video, so you can also check this one out. Okay, so super recommendable to watch. And then here are the references. Well, of course, this one came from All About Circuits. And then here are the other related articles, just in case that you still need more information when it comes to source transformation. So you can check the Circuit Globe or the People Clarkson. Okay, so yeah, that's how easy to solve a source transformation. So are we clear so far?
Yes, sir.
Yes, sir.
Okay. So if you guys are going to ask me, this is the easiest theorem that I've learned so far. Okay, so sobrang dali niya since it's all about transforming series to parallel and then parallel to series hanggang sa mag-arrive kayo sa series connection. So ganito. Okay, so that's it for the source transformation. Let's now move on to the delta-Y and Y delta transformation. So delta, the symbol of delta is of course this one, okay, and then Y is literally Y, okay, and then vice versa. So you can transform delta to Y and then Y to delta. Okay, that's why we have this kind of representation right here. Well, anyway, so just a short background. So the delta-Y transformation is an extra technique for transforming certain resistor combination that cannot be handled by the series and parallel equations. So again, there are some circuits that we cannot just easily or convert that one right away into a series connection or parallel connection. So if that is the case, then we have to use the delta to Y or Y to delta transformation. Okay. So this delta to Y, this is also referred to as a pi t transformation. So again, delta and then pi is just the same, just a different terminology. So the same with Y. Y is equal to t, okay, just a different terminology. So this one was written by Willie McAllister. So credits to this person. Okay, this one came from him. So let's now move on to the diagram, okay, or the default circuit diagram of a delta connection. So the reason why we are calling this one delta, okay, because as you guys can see, if you're going to invert this one, it is now similar with this kind of circuit. Let's just say that it's an inverted delta. But for Y, it's very obvious, wherein we have a Y circuit diagram in here. Okay, that's why it's called delta to Y, okay, transformation. So again, from here you can convert this one into something like this, or vice versa. You can convert this Y into a delta circuit diagram. Okay. Well, anyway, so just a fact, okay, not that really matters when it comes to delta to Y. So a delta, it composed of three nodes, so 1, 2, and 3, and then Y is composed of four nodes, so 1, 2, 3, and then 4. Okay, so again, you can transform this one, okay, this delta into pi, okay, configuration. So those two are just the same. Okay, it's just that from three nodes it will become four nodes. Okay, and then the same with Y. Okay, you can actually transform this one into T. So those two are just the same, but from four nodes it will become one, two, three, four, and then five nodes. So it's just that there is an additional one if you're going to use pi and then T configuration. Okay, but mostly, of course, we are going to use this kind of circuit. Itong nasa unahan. Kasi ang topic lang naman natin is delta to Y resistor networks. Well, you can also use this one. However, this one, you cannot easily solve this one using Ohm's law. So if you're thinking that they are in series, no. Okay, because we have a connection in here. So again, if it has a node on this part, wherein meaning there is a another component in here or another component above that, so you cannot easily add them. So the same with this part right here. Okay, so we have a node, so they are not in series connection. So at the end of the day, we're going to transform this pi configuration into a delta configuration. Okay, itong nasa taas na ito. Okay, it's just that parang guguluhin kasi kayo. Initially, bibigyan kayo ng pi configuration. Okay, it's not directly on the delta configuration kasi kapag nasa delta na siya, then napakabilis na lang. One step na lang and then you'll be able to convert that one into Y configuration. So initially, they will always give us this pi t configuration. And then your goal is to transform that one into a delta configuration. Okay? Well, anyway, so let's move on to the next one. So when it comes to label, we have this default labeling. Okay, so do not change this one to avoid confusion when it comes to your solution. So RA is on the bottom right, and then RB is on the bottom left, and then RC is on the top. Okay, and then when it comes to X, Y, and Z, so wherever is your IE, RA, so ang i-memorize nyo na lang, isa lang. Okay, kung hindi lang to open notes, ang technique na masasuggest ko, kasi syempre, online distance learning, it's open notes, so wala kayong pinaproblema. Well, anyway, the only thing that you guys need to memorize is this RA, RB, and RC right here. Okay, so once you have memorized those, then you can now easily point where is your X is. So RA, na lang, sulat ko muna, RA is equal to X, RB is equal to Y, and then RC is equal to Z. So it seems logical, right? So ABC is equal to X, Y, Z. Okay, correspondingly. So dito, ang para magiging pattern nyo, so wherever is your RA pointing, that is your X. Wherever is your IB pointing, that is your Y. Wherever is your RC pointing, that is your Z. Okay, so as a result, para magiging ganito siya. So we have a node right here. So additional node for Y configuration, right? So this will form a Y configuration. So parang ganun. Okay, RC going to Z, RA going to X, and then RB going to Y. Okay, so are we clear with that one?
Yes, sir.
Okay, one more thing. Of course, after transforming this one, it will give you a specific value on this one. So X is equal to, sulat ko na lang ulit dito, X is equal to R1, okay, and then Y is equal to R2, and then Z is equal to R3. Okay, so from here, meron pa ba yun? Okay, meron pa. From here, so magiging ganito siya. Okay, and then the extra node in here. Okay, so as you guys can see, this is the delta connection, the RA, RB, RC, and then the middle one is your Y connection. So parang yun na yung pinaka-pattern nyo on how to transform this delta into Y configuration. So wherever is our X, that is our R1. Okay, wherever is our Y, that is our R2. Wherever is our RC, okay, that is our R3. Okay. Well, anyway, that is the only tip or the pattern that I can give to you guys, and then the rest are now up to you. Okay, so kanya-kanyang parang style kasi. Okay, that's my style. Iba din yung sa YouTube. Okay, iba kasi yung parang natutunan ko sa instructor ko dati. So nakalimutan ko na kung anong pangalan nun. Pero yeah, ito yung tinuro niya sa akin. Okay, or sa amin pala. Okay, sa YouTube iba din. So nag-stick na lang ako kung sa ano yung naalala ko. So ito rin yung tinuturo ko sa inyo. So you can do the other pattern if you want. So as long as we'll arrive with the same result. Okay. Well, anyway, so for us to be able to solve this R1, we have this formula right here. So time check, 6 minutes left. So okay, kasya pa yan. Okay, so in here, when it comes to transforming a delta to Y, okay, so one thing that you guys will notice is our denominator is the same. Okay, That is from delta to y. So when it comes to equations or formulas, pwede nyong isulat ulit to. So from delta y, okay, so we have a common denominator. Parang pangit yung common na. Same denominator. Okay. So vice versa, susulat ko na rin ngayon. From y to delta, we have the same numerator. So, napakadali lang siyang tandaan. Okay, however, wag nyo lang pagpapalitin. Okay? Kasi pag pinagpaliktad nyo itong dalawang to, of course, mali na yung sagot nyo. Anyway, so when it comes to y to delta, we have same numerator. So you guys will see later on the formula for the y to delta. But for now, let's have this formula right here from delta to y. So when it comes to R1, so balik tayo sa drawing natin. When it comes to R1, we are solving this R1 right here, right? So as you guys can see, the side-by-side resistor is RB and RC. So yun lang yung kailangan natin. Oops. Those are the only things that we need for us to be able to solve this R1 right here. So RB times RC divided by RA plus RB plus RC. So when it comes to denominator, just get the summation of those resistance. So in here, for us to be able to get the R1, it's RB, okay, and RC. For if you want to get the R2, so the R2 is on this right side, upper right, and then the resistors next to it is the RC and RA. So just multiply those two with each other. So RA times RC, okay, divided by the summation of the resistance. So the same with the R3 right here. So it's RB times RA or RA times RB. Okay, so were you guys able to get that one? The pattern on how to solve the R1, R2, and R3?
Yes, sir.
Yes, sir.
Okay, so since this is open notes, so pwede nyo naman itong balikan kahit anong oras nyo kailangan. Okay, so yung sinasabi ko lang is parang para hindi nyo na, let's say, dayain yung sarili nyo. Yun na lang yung way para i-memorize nyo. Kung gusto nyo talaga matuto, just memorize this one. Okay, or familiarize, and then eventually you'll be able to recall the correct formula of this one. Okay. So yeah, that's it for the delta to y. So let's now move on to y to delta. So I mentioned a while ago that we have same numerator for y to delta. So there you go. So when it comes to y to delta, we have R1 times R2 plus R2 times R3 plus R3 times R1. So lahat sila pare-parehas na. Okay? And then, of course, RA is always equal to R1. Okay? So, R1 will be pointing out on this one. So, ito yung makukuha nyong value. Okay? And then the same with RB. Okay? RB, where is our RB? RB is equal with our R2 right here. So, balik lang kayo dito sa diagram na to para malaman nyo kung saan ba yung R1 natin and then saan siya equal. So, R1 is equal to RA. Okay, which is this one. And then RB is equal to R2. And then RC is equal to R3. So, yun yung parang magkaka-partner lagi. So, that is why this setup or yung parang standard labeling natin sa delta to y is very important. Okay, so we have the x right here, y, and then z. Okay, we have the RA right here, RB, and RC. So, kapag pinagpalit-palit nyo tong mga to, okay, you won't be able to apply this kind of formula anymore. Okay, mag-iiba na rin yung sagot nyo. If you want to stick with this kind of formula, R1 times R2, etc., etc., okay, you have to stick with the labeling also. Okay? So, there is no way na kapag pinagpalit nyo tong Z at saka X, tama pa rin yung sagot nyo. So, dapat alam nyo yung tamang positioning. Okay, if you want to use this kind of formula. Pero kung pinagpalit nyo, as long as you stick with the concept, you know, R3 times R2, kung sakaling R1 to, then R3 times R1. Ganun lang naman yung mangyayari. And then you will still arrive with the same result. Okay? So yeah, just an advice. If you want to memorize this one and then use this one all throughout when it comes to delta to y and then y to delta. Well, anyway, so are we clear so far when it comes to y to delta?
Yes, sir.
Yes, sir.
Yes, sir. Nagets po.
Okay, very good. All right, so time check again. We now only have 50 seconds, I guess. So we'll just continue the rest on the party. So goodbye for now, and then see you guys later.
Sige po, sir.
Okay. Okay, so can you guys see my screen now?
Yes, sir.
All right. So this is the last one, y to delta, and then the next one is this simple example. Okay, so the goal of this example is just to show you that using the formula of delta to y, we'll have this kind of value. But of course, we can revert it back into y to delta, wherein it will give us the same value if we're going to solve that one again. Okay, so for the delta to y, it gave us this kind of computation. Okay, so since you guys now have learned how to deal with those numerators and then denominators, so I'll give you guys a minute, okay, to analyze this one, and then yeah, on how did we come up with this one right here. Just verify, okay? Just would like you guys to verify since everything is already in there. Okay. Kasi one major flaw of this example, I cannot justify that RB came from here and then RC came from here, like RB and then RC. Since all of them have the same values. So 3, 3, 3. So parang yun, medyo nonsense. Pero again, the goal of this example only is just to say or to show that when it comes to converting this one into a y transformation, you will have this value. But when it comes to converting this one going back to delta, you will have the same value. Okay, so that's the main point of this first example. So just let me know once you guys are done with this computation. Everything is 1 ohm anyway.
Sir, gets naman po.
Okay. So mas ma-appreciate nyo yung next example mamaya. Anyway, this is from delta to y, which gives as this values 1 ohm. Okay. And then from y to delta, of course, with the use of the formula of y to delta. Okay. So it will give us this the same result or the original results. So again, I'll give you guys a minute. So the main goal of this example is just to convince you that from here to that conversion and then going back to the original one, this is still the same. Like parang sinasabi lang na tama yung uh, conversion or the logic behind it.
Gets naman agad.
Gets po, sir.
All right. So again, the main goal is just to prove that this one is the same if it will be a transform again to its original formation, okay, which is the delta. All right, and then here are the computations. Okay, so let's have a real example. Okay, ito na yung talagang parang makikita nyo pagdating sa mga quizzes and then when it comes to your exams. Okay, now for an example that's a little less tidy, we want to find the equivalent resistance between the top and bottom terminals. Okay, so try as we might, there are no resistors in series or in parallel, but we are not stuck. So first, let's redraw the schematic to emphasize we have two delta connections stuck one on the other. So ito yung para makikita nyo initially when it comes to your quizzes, exams. Okay, so if you guys are going to take a look at this one closely, parang pwede mo siyang i-combine Like parang ito nasa parallel lang, okay? Or pwede mong actually ito kasi may node pa dito. So hindi mo siya pwedeng i-combine like parang series connection. So parang pwede mong i-assume na this one is in parallel with this one. This one is in parallel with this one. This one is in parallel with this one. But that is actually already your hint. Okay? If everything is in parallel, like these three connections is in parallel with each other, that is already a delta connection. So if it's in delta, you cannot simply solve that one using a parallel rule connection, okay? Due to having a node right here and then another node right here and then another node right here. So parang kung i-stretch out nyo to, okay? So you can easily make a triangle. Okay, like for example this one, kung i-stretch nyo lang tong bilog na to pataas, okay? And then this one into pag ganun, and then ito pag ganun din. So, meron ka ng triangle, okay, which is now this one. Okay, the same with the bottom side. So, ito meron tayong 5 ohms, 4 ohms. So, same scenario. It's like you can say that this one is in parallel with 3 ohms. This one is in parallel with 4 ohms, 5 ohms. Okay, so, again, pag ganun, tatlo silang nasa parallel sa isa't isa, meaning that's already a delta connection or a delta configuration. So we have to transform this pi configuration into a delta configuration. So bakit pi? So I think very obvious din naman kung bakit siya natawag na pi. Okay, that's because we have this kind of circuit. Okay, or parang configuration. So it's like forming a pi connection. Okay, so the same this what it's just an inverted pi. Okay, anyway, so yeah, that's the reason why they called that specific configuration as a pi configuration. Okay, and this one is now a delta configuration. All right, so anyway, you have to transform this uh, 2 pi configuration into 2 delta configuration. Okay, so after that, then you can now perform delta to y or y to delta configuration. Okay, but in here, the one that we need is of course delta to y configuration. Okay, so saan kayo mag-umpisa? Is it on the upper or on the bottom? So either of those two will be fine. So ang common lang, common practice when it comes to combined delta configuration, we always start with the bottom. Okay, yun lang naman yung parang nakita ko na kapag meron combined laging sa bottom. Well, pwede ka rin namang mag-ano sa taas. Kaso nga lang, pagdating kasi doon sa circuit na tinuro ko kanina, okay, this one, baliktad na, medyo nakakalito. So that is why just stick with this kind of configuration. So we have this inverted delta. So that is why it's a lot easier to solve the bottom part first. Okay? But, and then after that, you guys will see later on that you don't need to solve the upper portion anymore later on. But anyway, so here's now the uh, labeled, okay, configuration. So we have here the RB, we have here the RC, and then RA, and then the X, Y, and then Z. So just always stick with this kind of labeling. Okay, once you have that, then you can now perform this kind of formula. Okay, so itong RB times RC divided by RA plus RB plus RC and so on and so forth. So from here, just apply that formula, okay, this formula right here, and then you will get this Y configuration, okay? RE is equal to R1, okay, or the X node right here, which is this one. RB is into Y or equal to Y or R2, and then RZ is equal to R3, okay, which is this bottom part right here, okay? So just simply apply this formula right here, okay? and then you will have this kind of equation. Just substitute the corresponding values for RB, RC, RA, okay? And then you will get this 1.25, 1 ohm, and then 1.66. So in here, I'll give you guys 2 minutes, 2 to 3 minutes to analyze this one, okay? And then apply what you've learned, okay, from our past slides that we have discussed. So just let me know once you're done, okay?
Gets naman, sir.
Okay. So yung the only thing that you guys need to worry when it comes to delta to y configuration is the numerator. Okay. So para mabilis siguro kayo, let's go straight with the computation. Okay. So if you want to solve this part right here, let's say this is the R1, R2, naglalag. Okay, and then this is the R3. So for the R1, wherever is your RA pointing, this part right here, that is your R1. Okay, RB, wherever it's pointing, it's your R2, and then this one is R3. So if you want to solve for the R1, okay, just deal with the uh, resistors next to it, okay, or kung ano man yung katabi niya. Okay, so we have RB and then RC right here. So just multiply that with each other. So 5 times 3 divided by the total resistance, okay, which is 4 plus 5 plus 3. Okay, so 5 times 3 is 15 divided by 4 plus 5 plus 3 is equal to 12. So 15 divided by 12 will give you this result. So if you want to solve for R2, then you're dealing with this 2 resistors right here. So 3 ohms times 4 ohms, which is 12. If you want to solve for R3, then you're dealing with this RE and RB, which is 4 times 5 ohms, which is now this one. Okay, and then you have the same denominators, which is 12. So here 12 divided by 12 is 1, and then 20 divided by 12 is 1.66. Okay, so were you guys able to get that one?
Yes, sir.
Yes, sir.
Okay,
Nagets
great.
po, sir.
So yeah, that's it for the first transformation. Okay. Well, anyway, that's actually the first and last transformation. Okay. After having that one, you will now have this Y. Okay, Y configuration on the bottom. Of course, R1 is 1.25, and then R2 is 1 ohm, and then R3 is 1.66. And then as you guys can see right here, you could see that they are now in series connection. Okay, this 4 ohms plus 1 ohm. Okay, this, and then it's 3.125 plus this 1.25 right here. So you can even make this one into something like this, just to say that they are now in series and then in series. Okay, so after combining those two, you will have these values: 4.375 and then 5 ohm right here. Okay, and then after that, you can now say that they are really now in parallel connection. Okay, since we now have separate nodes right here, we don't have another node right here or another node right here which will conflict, to say that all of them are in parallel connection, or some of them are in series connection. Okay, so in here we could say that this one is really in parallel. So 4.375 times 5 divided by 4.375 plus 5. So just apply the formula of a parallel connection, and then you will get 2.33. So after combining them, of course, it is now in series connection with this 1.66 ohms. So 2.33 plus 1.66 is 3.99, or let's just say 4 ohms right here. Okay. So there you go. We now have a single resistance from 1, 2, 3, 4, 5, from 5 resistance into a single resistance. Okay. And then mostly the case of this one. So the scenario right here. Okay. So at this point, we have a connection right here. And then at this point, we have a connection right here. And then this is your voltage source. So that is always the case. So parang nagkaroon na lang tayo ng ganitong connection. Okay. And then you can now, of course, easily solve the voltage drop across this resistance, or the current, or the total current. Okay. And then, yeah, those are the things that you can do once you've arrived at this kind of circuit. Okay, so are we clear so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, but mind you guys, just a warning. Okay, so ito na rin yung parang magiging hint nyo when it comes to your final exam. So the questions, of course, in final exam will be, what is the voltage drop across, let's say, R1, okay, or R2? What is the voltage drop across R3? Or what is the current that is flowing on RT? Okay, so yun yung mga questions na kailangan nyong sagutan pagdating sa exam nyo. So that is why it's important to know what is the individual resistance of that R2, individual resistance of that R1, and then what is the current that is flowing on that specific node. So we have to carefully analyze the circuit. Okay? So yeah, yun lang naman yung advice ko. So just a summary, so Delta-Wye transformations are another tool in your bag of tricks for simplifying circuits prior to detailed analysis. Okay, so don't memorize the transformation equations. If the need arises, you can look them up. So this one came from Khan Academy. Okay, so here are the other related articles. So of course, we also have all about circuits. Pero mas nakita ko lang kasi na, I think before, because I created this one last year. Okay, so para mas madaling ituro, okay, or mas madaling maintindihan yung nasa Khan Academy. So that's the reason why nag-switch ako sa Khan Academy for Delta to Y transformation. But nevertheless, if you want to learn more, okay, you can visit those 4 websites. So number 1 is www.allaboutcircuits. We have spinning numbers, another spinning numbers. Naulit to ah. Okay, naulit lang yata. E delta to Y resistor networks. Yan, naulit nga lang. So na double paste ko yata. And then the last one is, oh, bakit parang naulit ko rin yata to? Direct current, chapter 10, delta to Y. Ay, naulit ko lang. Okay, there's only 2 related articles, the all about circuits and then the spinning numbers. Okay, so just check those websites. Okay, and then for sample videos, so feel free to visit this example on YouTube. So, ito lang yung parang nahanap kong madaling maintindihan. So, marami namang iba pa. Okay, you can find more another videos for that specific topic. Okay, but these are the only thing that I think the easy to understand or easy to answer or analyze for beginners. But if you want a Tagalog video, then you can also visit this one. Okay. So yeah, that's it for the delta to Y transformation. So that's it for today's discussion. So baka medyo nama-mind blown kayo. Parang kasing in just 1 week, we were able to finish 4 modules in total. So at the same time, 4 quizzes na rin yung parang sasagutan nyo. So don't you guys worry. Sinasadya ko talaga yon para may marami kayong time, para hindi kayo naghahabol ng oras pag let's say 1 week na lang before the final exam, and then hindi nyo pa tapos yung mga kailangan yung tapusin. So para kapag marami pa kayong oras na natira, then pwede nyo gamitin yun as your time to review, as your time to finish the activities on your other subjects. Okay? So next meeting, this coming Monday, July 26. So we're going to discuss the remaining 2 modules. Okay, so don't you guys worry. Mabilis lang talagang tapusin yung sa finals. Okay, mas madali pa nga kung tutuusin as long as you know the fundamentals. Okay, so ipinablish ko na dito. Just download them and then do an advanced reading para mas maintindihan nyo na bago pa yung official na discussion natin. Okay, but again, don't forget that we have an additional 2 quiz, just like what I mentioned a while ago. So the due date of this one is August 5. Okay, source transformation and then delta to y and then y to delta transformation. Okay, and then for the remaining 2 modules, we're not going to have a quizzes for those anymore. Okay, so after the discussion on Monday, final exam na lang yung matitira. Okay, which is this one. All right, so are we clear so far?
Yes, sir.
Okay, so we still have plenty of time. If any of you has a question, so feel free to ask me.
Sir, question lang.
Okay, ano yun?
Sir, after po ba ng final examinations, may parang break time, sir?
Meron naman 1 week. Like, yeah, literally vacation na yun. Semester break. Pero saglit lang. Okay. You're transferee, right? If I'm not mistaken.
Hindi naman po, sir.
Oh, bakit mo tinatanong? Dapat alam mo na yun. Okay, may break naman tayo. Lagi namang meron. Okay, like 1 week. Okay, or more or less 1 week. Parang ganun lagi. And then after that, enrollment. And then after that enrollment, of course, pasukan na naman. Okay.
Okay, sir. Thank you, sir.
Alright, so any other concerns?
Wala naman na, sir.
Okay. So, yeah. Para makakain na rin yung mga hindi pa kumain. So, if you guys don't have a question anymore, then just give me a thumbs up again and then you may now go. Okay. And thank you guys
Thank you,
for coming.
sir.
Okay.
Thank you, sir.
Thank you too.
Bye, sir. Thank you.
Goodbye and thank you.
Bye,
Thank you,
sir.
sir.
Goodbye and thank you too.